Here is the question I keep returning to. Why does Antarctica have the geography it does? Not the ice, the land underneath it. The continent buried beneath 2 miles of glacial compression has mountains, valleys, lakes, and river channels. It carries the topography of a place that was once alive, and I don't mean that loosely. Radar-mapped surveys conducted under NASA's Operation Icebridge and the earlier BedMap projects have produced detailed images of the subglacial terrain. What they reveal is not a geologically inert platform. It is a landscape of extraordinary complexity, one that in other latitudes we would describe without hesitation as habitable. That on its own is not suspicious. We understand that Antarctica was not always a frozen continent. Geology tells us it was once positioned closer to the equator, covered in forests, warmed by a temperate sun. The evidence is in the coal seams, in fossilized fern imprints found near the pole. The scientific consensus holds that Antarctica drifted to its current position over tens of millions of years through the mechanisms of plate tectonics. By roughly 34 million years ago, the continent had separated from South America. The circumpolar current formed, isolating it thermally, and glaciation followed. This is the accepted framework, and it is well supported. I am not here to argue with plate tectonics. What I am trying to do is sit with a different question, one that the geological timeline raises, but does not answer. If Antarctica was temperate long enough to grow forests, then something lived there, and possibly for a very long time. The question is not whether plant life flourished in an ancient, unfrozen Antarctica. We know it did. The question is whether, in that long window between temperate climate and total glaciation, a window that may have lasted millions of years, something more complex had the opportunity to emerge and take root. Now here is where I want to slow down. In 1513, a Turkish admiral and cartographer named Piri Reis compiled a world map drawn from older source charts. That map survives and is housed in the Topkapı Palace Museum in Istanbul. It depicts the coastline of Antarctica. The problem with that sentence is that Antarctica was not officially discovered until 1820. The continent did not appear on maps until the 19th century, and even then only its ice-covered edges. Piri Reis drew it 3 centuries earlier, and drew it in critical sections without the ice cap that covers it today. This has been studied seriously. In 1960, Lieutenant Colonel Harold Z. Ohlmeyer of the United States Air Force Strategic Air Command wrote to Charles Hapgood, confirming that the subglacial topography depicted in the map matched recently completed seismic profile surveys of the continent. The Air Force did not dismiss the finding. They confirmed it. I want to stop and be fair about the counter-argument, because it is not a weak one. Scholars have pointed out that Piri Reis's map contains significant distortions elsewhere. Some argue that the apparent Antarctic coastline is a misplaced or speculative rendering of South American geography. That argument deserves genuine weight, but here is what that argument does not explain: the interior features. Not just the coastline shape, but the sub-ice rivers and mountain ranges that Hapgood and later researchers identified as matching the 1958 seismic profile, features that no speculative extrapolation from South America would have generated. The interior is the problem. Hapgood, who analysed anomalous ancient maps in Maps of the Ancient Sea Kings, was not a fringe thinker. His hypothesis on crustal displacement received a prefatory endorsement from Albert Einstein, who wrote that the idea deserved serious consideration from geologists. That letter is rarely mentioned in the same breath as Hapgood's Antarctic observations. And then there is Lake Vostok. Sitting beneath 2.3 miles of Antarctic ice, it is one of the largest lakes on Earth, a body of freshwater roughly the size of Lake Ontario, sealed from the atmosphere for somewhere between 15 and 34 million years. Russian drilling reached its surface in 2012. What they found was not a sterile environment. Bacteria survived in the water. Novel microbial forms, unlike anything catalogued in surface ecosystems, were present in the samples, though the Russian team faced significant criticism over contamination protocols, which made the findings difficult to evaluate cleanly. The debate about the microbial data is ongoing and unresolved. But what I keep coming back to is the thermal data. Lake Vostok maintains a temperature of approximately -3 degrees Celsius, which is above freezing only because of the enormous pressure the ice exerts upon it. That pressure also produces heat. The water is not frozen, it moves, it circulates, and it is not alone. Scientists have mapped more than 400 subglacial lakes beneath the Antarctic ice sheet. Some are connected by an elaborate network of subglacial rivers that drain and refill on timescales of years. There is a hydrological system of remarkable complexity running beneath the continent, largely out of sight. Beneath several of those subglacial lakes, geothermal heat vents have been confirmed, warmth sources that operate independently of surface climate. In the oceans, around similar hydrothermal features, we have found ecosystems of remarkable density existing without sunlight, sustained entirely by chemical energy rising from below. Life does not require the conditions we assume it requires. Now I want to bring in a different thread, one that has gone unresolved for a long time. In 1946, the United States Navy launched Operation High Jump, commanded by Rear Admiral Richard Byrd. It was the largest Antarctic expedition in history, 4,700 men, 13 ships and 33 aircraft, with a stated mission of scientific research. The operation was cut short. The official explanation is weather. Antarctic conditions deteriorated faster than anticipated, making continued operations unsafe. That is a reasonable explanation, but the expedition was planned for 8 months, and it ended after 8 weeks. 3 aircraft were lost, several crew members died. Byrd departed without completing the stated objectives. What Byrd said publicly afterward is worth examining carefully. In a 1947 interview with the Chilean newspaper El Mercurio, transcripts of which have been preserved, Byrd spoke of a potential threat originating from the polar region, aircraft that did not behave like aircraft, capable of movement at speeds that were operationally impossible in 1947. I recognize how that sounds, and I want to be careful here because the Byrd quote has been weaponized by fringe communities to a degree that makes honest analysis difficult. The full interview context includes concerns about Soviet military capability, which provides a plausible Cold War reading of his words. That reading is legitimate, but the timing is what I cannot square with the Cold War explanation. Operation High Jump preceded the Berlin blockade. It preceded the formalization of NATO. It preceded the Soviet detonation of their first nuclear device by nearly 2 years. In 1946, the Soviet Union was not yet the defining military threat it would become. So why Antarctica? Why that scale? Why 4,700 men and a combat-equipped naval task force for scientific survey? The Navy does not deploy aircraft carriers for geological study. The organizational structure of High Jump, its command hierarchy, its aircraft complement, its radio silence protocols, was not the architecture of exploration, it was assessment. What troubles me most is not any single element, it is the consistency across disconnected sources. A 16th century Ottoman cartographer, a mid-20th century American naval command, NASA radar surveys, Russian drilling programs, the International Geophysical Year of 1957, which sent 12 nations simultaneously to Antarctica for the first time in coordinated human history. 12 nations, many at ideological war with one another, agreed in the same year to coordinate research in one of the most hostile environments on Earth. The Antarctic Treaty of 1959, signed by those 12 states and since extended to over 50, demilitarized the continent and restricted access to approved programs only. I am not suggesting the Soviet Union and the United States conspired to conceal something beneath Antarctic ice. I am saying something more structural and, in a certain way, more disturbing. That institutions sometimes arrive at identical behavior through shared interest alone, without any meeting, without any document, without anyone stating it openly. There is a term in evolutionary biology for when two entirely separate organisms develop the same adaptation to solve the same problem: convergent evolution. The eye evolved independently at least 40 times in different species. The wing emerged separately in insects, birds, and bats. The same pressure applied in different places produces the same form. Institutional silence works the same way. When a discovery is sufficiently destabilizing, not to governments, but to the entire architecture of what civilization understands itself to be, the response is not coordination, it is simultaneous conservation. Each system, independently, reaches the same conclusion. This cannot be released as it is. The Ipica Ice Core Program, a joint European initiative that extracted cores from Antarctica reaching back 800,000 years, produced climate records of extraordinary resolution. Those records show that the transition to full Antarctic glaciation was not a single abrupt event, but a series of steps, advances and retreats spread across millions of years. What that means practically is that for extended periods during glaciation, significant portions of Antarctica would have remained exposed, not warm, but not sealed. Ice-free corridors, accessible river systems, lakes that had not yet frozen, a slow burial with pauses, time for anything present to adapt, to move, to go deeper. Consider the Gamburtsev subglacial mountains, revealed in their full extent through the AGAP project in 2008 and 2009. These peaks rise to nearly 2,700 meters above sea level, comparable in height to the Alps, yet they are completely invisible from the surface, buried entirely, unmapped until radar surveys documented them in detail. That is worth sitting with. A mountain range the size of the Alps, hidden under ice, unknown to science until the 21st century. The geologists who found them were baffled by their sharpness. The peaks showed very little of the glacial erosion one would expect after tens of millions of years of ice coverage. The leading hypothesis is that the mountains were protected, insulated from full glacial contact by ice that moved over rather than through them. It is a coherent explanation that accounts for the data, but it does not address what occupied those valleys between those peaks before the ice arrived, because those valleys would have been extraordinary, protected on all sides by mountain ridges, running at a latitude where, in the era before glaciation, temperatures would have been comparable to present-day Scotland, freshwater drainage from the peaks, a river system feeding a basin, stable thermal gradients, and time, Millions of years of it? Here is where I have to be careful, because this is where the reasoning wants to accelerate past what the evidence actually supports. The presence of conditions sufficient for complex life is not evidence that complex life existed there. I know that. A habitable place is not the same thing as an inhabited one, but I also know this. In every region of Earth where conditions for complex life existed and time was sufficient, complex life did not merely survive, it organized, it built. It developed the adaptive behaviors that represent, in retrospect, the unmistakable signature of intelligence working across generations. What unsettles me, and not because it is certain, but because it cannot be cleanly dismissed, is not whether something lived in those pre-glacial Antarctic valleys. It is whether something that lived there long enough would have left traces now sealed 2 miles beneath the ice. Stone does not rot. Architecture, when compressed, deforms but does not vanish. The sedimentary record in subglacial lakes captures what was present on the surface before glaciation. Scientists have already begun extracting sediment cores from subglacial lakes, and those cores have shown that the pre-glacial Antarctic surface was extraordinarily biologically active. A new generation of drilling programs is being proposed for the deep subglacial lakes, not just Vostok, but Lake Ellsworth, and the lakes mapped beneath the Thwaites Glacier drainage basin. The containment protocols for these programs exceed what standard microbial contamination concerns would typically require by a significant margin. I want to be fair to the engineers who designed those protocols. They are cautious people doing rigorous science in an irreplaceable environment, and the protocols may simply reflect a general commitment to planetary protection standards that have grown more conservative over time. That is the rational explanation, and I genuinely cannot rule it out. But containment protocols are designed in response to specific categories of risk. You contain for what you expect to find, or what you suspect might be present, and the previous subglacial surveys, seismic profiles, gravity maps, electromagnetic readings, contain anomalies that have never been publicly explained. The gravity anomalies beneath the East Antarctic ice sheet are particularly difficult to account for using standard models of subglacial geology. They suggest mass concentrations at depths and in configurations that do not match the surrounding terrain. The natural explanations are dense mineral deposits, batholithic intrusions, or geothermal features. Scientists continue to study them. What science has not done cannot yet do, given current drilling capability and access restrictions, is image those anomalies at the resolution that would definitively rule out structural regularity. And structural regularity in subglacial features of this kind is the thing that would matter most. The ice is not forever. The Antarctic ice sheet is losing mass at a rate that has accelerated measurably over the past 2 decades, driven by warming ocean temperatures and atmospheric change. What is buried beneath it will not remain buried indefinitely. The timeline of the ice's retreat is a subject of active scientific measurement. I think about who will be standing at the terminal when the first high-resolution scan comes back from the Gamburtsev Basin. I think about the expression on a scientist's face in the moment before they decide who else gets to know what they are looking at. I do not know what is underneath the Antarctic ice. I am not certain that anything remarkable is there at all, but I know that the shape of the silence around this subject has a particular quality, the quality of something protected rather than something absent, and the difference between those two things is everything. The question is not whether the ice will eventually yield what it holds. The question is who will be in the room when it does, and whether what they find will travel upward into the light or settle quietly into the same deep silence that has held it for so long already.